this is what I kind of want to do to practice. I want to kind of look at these series, and the first thing I want to do is talk about what test works the best. And then I want us to kind of outline, without going through all the details, what things you would have to do. So let's take a look at these. Number 2, what test would work best for that series? Comparison or limit comparison, right? Good. And what would you be comparing it to? Harmonic series. Good. Which does what? Good. Thank you. Good. So we're not doing all the details, but we're taking a look at this and trying to decide what to do. What about number 4? Yeah, anytime you see this, you're thinking what? Alternating series test. What are the 3 things you have to show for alternating series test? Positive, decreasing, limit is 0. Do you think, without showing all the details, do you think it would satisfy all 3 of these? It does, yeah. The hardest one to show is the decreasing part, right? Write it as a function, take its derivative, show that it's negative. So do you have a gut feeling about whether this would converge or diverge? Converge, right. Notice these are exactly the same except for one alternates and one doesn't. So what do we call that? When the alternating converges, but the one with all positive diverges? Conditionally convergent. That's the one that we call this conditionally convergent. Okay, what about 6? What's your gut feeling that we would do on that? Comparison test again, right. Okay. Comparison or limit comparison. And probably with 1 over n again, right? Because looks like that's our most important term. This one's always n. This one could be smaller than n. All right, what about 8? What test do you think? Ratio test. Any gut feeling as to whether that would converge or diverge? Some people say diverge. Anybody say converge? She said converge. I would agree with converge because this one is more than this one here, right? But we have to take a look, okay? So I would practice this one. Okay, I think actually the more I look at it, I think it's going to diverge. You'll have to take a look at it. What about 10? Can you think of a good test for 10? Integral test. I like integral test. That works. Remember, for your f of x, it has to be continuous, positive, and decreasing. There's another test that would work, though. How about ratio test again? Ratio test would also work. Anytime you have a number to a n power, whether it's n squared or n cubed, okay? Whoops. Ratio test also works. Either one works. What about 12? Alternating series. Probably going to compare it with, not comparing it. We just said alternating series test. Do you think it would converge or diverge? Yep. It should converge. What about 14? agree that if I wrote this or this, you would have alternating. But these are kind of jumping all over the place, aren't they? Sometimes they're positive, sometimes they're negative, and they won't be automatically plus, minus, plus, minus, plus, minus. They might be plus, plus, minus, 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 plus, 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 right? You see what I'm saying? So you can't really say it's an alternating series. Certainly they're not all positive. They are bounded. What about the nth term test? What happens if you take the limit as n goes to infinity? Is this 0? No. No, right? Sign goes like this. There's no way a series can converge if the terms don't approach 0. Diverges. Okay. Question. Yeah.
Will something like this be posted on campus somewhere?
Yeah. I'll post it. Yeah.